All right, we're in Chapter 9, Polar Coordinates. We're going to look at the first two sections today, polar coordinates and polar equations. We've been graphing all your life in x and y. You go over x, you go up y, and you got your point. Now we're going to graph in the y, or the polar graph, which has an r and a theta. R is your radius, theta is your angle. In your notes, I told you how to use those numbers. Look at a couple examples. If you wanted to go 245, you'd go to the right 2, and then you'd go up a 45-degree angle. If you wanted to do negative 3 pi over 2, you'd go left negative 3, and then 90 degrees in a counterclockwise. You can see our third example there and how we ended up with that. Now, if I give you a point, like on the bottom, it's the point 7, 120 degrees. There's 4 different ways you could write that, and I'll work them out for you here. One way is to go in a negative angle. So 120 degrees is the same as negative 240. You could also go negative 7 and then around 300 degrees and get there, and negative 7 and up negative 60 degrees and get there. Simple polar equations, those would entail circles. So if I just give you a radius, all you have is a circle to work with. There'd be no theta in your answer. If I give you just a theta, like theta equals, 30 degrees or 150 degrees, it's just a line. We can find the distance between two polar points. This is going to require a little bit of trig, specifically the law of cosines. Your book does a nice job talking you through it, but if you recall, the law of cosines looks like that. So if you have 2 points, your formula for it would look like that. An example, if I gave you a point 1 pi over 6 and 5, 3 pi over 4, plug the numbers in, use your calculator, and you can approximate it to be 5.35. The last part I'd like you to look at your book for, but we talk about the 5 special polar coordinates. Those are roses, lemniscate, limason, cardioid, and the spiral of Archimedes.